Okay, so I was reading your comments about why you did 10 times 9 because you said the last problem did that. But the key thing you have to understand is why did the last problem do that? If you're just mimicking a problem, you're not going to get anything right on the test. You got to understand why they're doing it. So the last problem said, um, essentially, what's the probability if that both the numbers are different? So essentially what they're saying here is, well, if they're both different, the first one we have 10 choices. Then for the second one, if the second one can't be the same number, now we only have 9 choices. That's why it's 10 times 9. Here, what we're saying is there's a sequence of 4 digits, not necessarily different, that are all 0 to 9. So again, we have 10 choices. Find the probability that 3 of the 4 digits are the same. So the previous problem was different. This one is they want them to be the same. So here we go. So here's how I see the problem. First thing I say is, okay, there's 4 digits. I just kind of draw them out so I can see them. Now the first thing I do is say, all right, 3 of these are going to be the same. Which of the 3? Maybe it could be that one, that one, that one, or that one, that one, that one, or that one, that one, that one. We have lots of choices. So first thing I'm going to do is do 4 combinations of 3. So out of my 4, I'm going to pick 3 of them to be the same number. So this takes care of counting up all the different ways of picking this. So now that we've done that, and it is a small enough one you can actually just count it out, but long story short, who cares? There you go. So 4 combinations to 3. That takes care of, okay, so now it takes care of saying, okay, it's those 3. Now we know those 3 are going to be one number. They're all going to be the same number. So how many numbers do I have to choose from for them? Well, I have 10, and I need to pick 1. Right? Now that I've selected the number for those, I have to select a number for this one. So there's only 9 numbers left, and I have to pick one of those. Now, you probably don't usually write them out this way, but I mean, what is 10 choose 1 or 10 combinations 1? That's just 10. What is this? That's times 9. So there's your 10 times 9, because we're going to have 2 different numbers to fill in all 4. And then this here, the 4 combinations of 3, as you saw, we just wrote them all out, but that is 4. And you can do that in your calculator. You can do it the old-fashioned way. So the answer here, what I'm seeing, I believe, should just be 10 times 9, which is 90. 90 times 4. So that, if my brain is working, that makes 360. Well, it would be easier. 4 times 9, 360. Yeah, 360. So now, the numerator, 360. Now, for the denominator. Well, the denominator says there are no restrictions. They don't have to be the same number. They can be. They could be different. So now we're just going to go through and say, okay, how many choices do I have for the first one? 10. How many choices do I have for the second one? 10. Third one? 10. Fourth one? 10. So it's just 10 to the 4th. So over 1,000. So this would simplify down. So it's just 36 divided by 100. So this would just be 0.36. Excuse me. I have one too few zeros. 10 to the 4th, not 10 to the 3rd. So we need to put another 0 there. Okay, so now when we do this, it would come out to be, excuse me for that, so that would make it not 0.36, but 0.036. There we go. Sorry about that denominator there. But hopefully that made sense. As long as you write enough zeros when you do 10 to the 4th, it should work out just fine. But the bigger issue here is making sure you understand why we do everything that we're doing, and the big thought process. Okay?